So we are looking at 1.5. And 1.5 is entitled More on Slope. So in this section, we're going to be looking at finding slopes and equations of parallel and perpendicular lines, interpreting the slope as a rate of change, and find a function's average rate of change. So let's fill in the blanks here. If two non-vertical lines are parallel, then they have the same slope. And what's it mean for lines to be parallel? Parallel lines are lines that never intersect. So on a graph, what you would see is two lines that look like this, for example. So this would be, we'll call this line 1, and we'll call this line 2. And so the two lines are the same amount of distance here and the same amount of distance here. So everywhere, no matter how far you extend the lines in either direction, it would be the same distance apart. So then you could say that line 1 is parallel to line 2. This notation here is the shorthand to state parallel lines. Now, the next sentence here says if two distinct non-vertical lines have the same slope, so if you look at the equation and you see the same slope, then you can assume that they are parallel lines. So it works both ways. So if you have two lines that are parallel, then you can say they have the same slope, and the reverse is true also. Now, it says two distinct vertical lines with both with undefined slopes are also parallel. So on our graph, it would look something like this. So here's my XY plane. And we learned in 1.4 that parallel lines, vertical lines are lines that go up and down, and their slope is undefined. So if you have two vertical lines and their slopes are undefined, they're also parallel to each other. All right, continuing. Let's see how we're going to use this information. So we have a question here that says, write an equation. So the first thing I see there is it's telling me to write an equation. And when I see write an equation, I should automatically think either I can choose this point slope form, or I can choose the slope intercept form. I can do it either way. It doesn't matter. So I should write that down. And then if you use the point slope form, you should fill in these three items. So let's go back to the question. It says write an equation of a line passing through this point, and that's parallel to the line whose equation is this. So this is line 1. So I'm going to say line 1, is y equals 3x plus 1. So pause the video for a minute and figure out from this equation, what would you say the slope is and what is the y-intercept? Remember that if you are in slope-intercept form, then your equation is solved for y, and the slope is the coefficient on the x, and the y-intercept is the constant by itself. All right, so now you should be back from the pause, and you should have got the slope of 3 and a y-intercept of 1. So I'm going to use that information. The information that I'm going to use that's important in this case is the slope, because I am told that this line I want to write the equation for, so I'm going to call it line 2. It goes through this xy point, so let's call this x1, y1, and it's parallel to this line. So I can use the slope there. So I'm going to plug in. I'm going to leave blank spots for these 3 items. And I'm going to plug in the slope, because they have the same slope, because as soon as you see parallel, you know that the lines have the same slope. And then they give me a point, one of the points on the line. And so my y would be 5 and my x would be -2. And now it's just a matter of cleaning this up. So I'll say y minus 5 is equal to 3x. Well, before I do that, I need to, this is going to be plus 2. And then I distribute the 3. So this is 3 times x, and then 3 times 2. And now last, typically I want to write these in slope-intercept form. So since I want to solve for y, I'll have to add 5 to both sides. And I end up with y is equal to 3x plus 11. Now, you can look at these and see that they have the same coefficient on the x. So they have the same slope. And you can also take both of these and you could put it in your graphing calculator and just verify that they look parallel to each other. So let's do that. I'm going to pull my calculator, and you should pause the video, grab your calculator, and do the same thing. So graph both of these. So in order to graph a line, you want to hit the y equals key. Your lines have to be solved for y to graph them in this calculator. You can also use an online calculator called Desmos, and we'll pull that up also probably in a future video. But here we have our calculator, and then we're going to put in 3x plus 1. This was the original. This is line 1, and this is the one I found. And then when I hit the graph, I can see they do look parallel. Now this screen is a rectangular screen, so it's not going to look precisely parallel. It actually doesn't exactly. If you want a square screen, you can hit the zoom button, and number 5 says square. So now you can see that now it squares up the what you see, and you can see that they look pretty parallel. So, and I'm just using the calculator to kind of verify it. It's not a method to really test it for sure. You can look at it and see the slopes are the same. All right, so that is about parallel. Now we're going to move on and talk about perpendicular. So perpendicular lines, those are lines that when we look at them, so I'm going to draw it out first. They are lines that one goes upward and the other one goes downward. And they intersect at a 90-degree angle. So this angle at intersection would be 90 degrees. And we'll see another line where, and it's this last one, we'll get to it in a minute. But if you have non-vertical lines that are perpendicular, the product of their slopes is -1. So what does the word product mean? The word product means the end result of multiplication. So if you were to take the slope of line 1 and multiply it by the slope of line 2, you would end up with -1. So let me write what I had said, but I didn't write it down. Perpendicular lines intersect at a 90-degree angle. If the product of the slopes of two lines is -1, then you can assume the lines are perpendicular. So just like the parallel lines, this statement that we made at the beginning here works both ways. And then the last statement, a horizontal line having a 0 slope is perpendicular to a vertical line having an undefined slope. So we learned in 1.4 that horizontal lines have a slope of 0, but vertical lines have undefined slope. So if you have two of those special type of lines where here's my horizontal line and here's my vertical line, those also will cross at a 90-degree angle and they would be perpendicular. So now this one, if you have, let's say that this is the slope of line 1. So the slope of line 1, in the case of this one on the left-hand side, let's say the slope of line 1 is 2/3. I don't know what it is. I'm just making it up. And I could figure out the slope of line 2 just by being given this. The slope of line 2 would have to be what I would multiply this to get to -1. So when you are doing this, I know when I say multiply it by something to get to -1, it might seem a little confusing. What do I multiply it by? But what you should do is take the slope, take the reciprocal of it, so flip the numerator and denominator, and then make it the opposite sign that it is. So if you have 2/3 and -3/2, when you multiply those together, you will end up with -1. And remember, I told you that one of the lines, besides this case here, the third situation, one of the lines has to go upward, and we learned in 1.4 if the line goes up from left to right, it's positive. And one of the lines has to go downward in order for them to intersect at a 90-degree angle. So the line would have to have a negative slope. They have to have opposite signs on their slope. So, for example, if I told you that I have a line and the slope of line 1 is -2, the slope of line 2 would have to be, think of this as -2/1. It would be flip the numerator and denominator and make it the opposite sign. So these two would look perpendicular on a graph. So we're going to look at this one next, and we'll do that in our next video.